Right, in this video, I'm going to introduce you about the meanings of direction ratios and direction cosine, and I'm going to derive the formula for direction cosine. Means that in this case, we're going to using the angle as an indicator to the direction of the vector. All right. So, for example, I have a vector from O to P, right? O to P, which is a position vector. So, and I write this position vector from O to P as AI plus BJ plus CK, as A, B, C. A is the value, means the x coordinate, right? The x coordinate, the length from the x-axis, and B on the y-axis, and C on the z-axis, right? And the values, the direction ratio, all right? The direction ratio. What is the meaning of direction ratio? Direction ratio is defined to be the value of A to B, B to C, ratio of A to B and C, right? So this is called direction ratio, means the number here, the ratio of this number is named as the direction ratio. So now, but the most important thing I want to introduce here is direction cosine, means that this vector is actually a 3-dimension, right? So this vector point P is not on the board, right? I draw it here because that's why I draw orthogon here to tell you that this point is actually on the air, right? So if I draw from O to P, right? O to P. So when I'm drawing O to P, this vector is actually making an angle to the x-axis, all right? You can see it's actually making an angle to the x-axis here. Right, so I can name his from, means that, okay, can you see that if this is a vector, okay, let's look at this. If this is a vector P, this is a point P, right? Your point P. So this is your x-axis. The angle between the x-axis to this vector, right, is this one, right? This is the angle from x-axis to this vector. And how about this vector, all right? This vector, so from y-axis to this vector, right? They are making an angle, and the z-axis also making an angle to this vector, right? So there are 3 angles. So the first one I'm going to introduce is the angle alpha, right? The alpha. Alpha is the angle from the x-axis to this vector, all right? So now, very simple. So I'm going to draw that in this diagram here. So it means that the alpha is from this to this vector, right? So from my eye, right? From my eye, I'm viewing from here, right? I can see that actually forming a triangle on this. I want to project, all right? I want to project this thing here, so that I can draw a triangle. So if I'm drawing from here to here, right, from drawing to here to here, so I can actually drawing a right angle triangle, right? I can drawing a triangle, if you see carefully, because this is 3-dimension, it's very hard for me to show here. So as I want to show you that if I view my eye from here, I can see that this is actually a right angle triangle, which if I draw out, I will see there is a triangle from O to P, and P to A will be forming a 90-degree, all right? It's orthogonal. So it's actually forming a 90-degree here to the line OA, right? PA is perpendicular to the line OA. So it means that OA, right? OA, so OA, and here will be 90 degrees. So where is the alpha? So if you see carefully, this is a triangle, right? This is a triangle. I transfer the triangle to 2 dimensions. So AP become this side, and OP will be the vector, the magnitude of the vector, and OA will be the length of the side OA. All right. So this will be the angle alpha. All right. So I name this to be angle alpha. Right. So I hope you can see. So this alpha, I just drawing a triangle from OAP, right? PA is perpendicular to OA, right? PA is perpendicular to OA, and this is the O to P, right? O to P is a vector. So now again, I'm going to show you how to find the angle between from the y-axis to this vector. Alright, now I'm going to show you the angles from y to the, how to find the angles from y to the vector here, right? So it's actually this vector. It's from this to this vector, right? It's angle from the y-axis to this vector. So we name it to be beta. For this, we name it to be beta. So it means that it's same from O to P, right? From O to P. So now it's from the point B here, right? This one, this point B here, all right, to this. So I can drawing a triangle here, right? Can you see carefully? If I drawing a triangle here, right? I drawing a triangle here, but you know that PB is on the side of the cuboid here, right? So PB is perpendicular to OB, right? So means I draw PB is perpendicular to OB, right? OB, which if I draw is O to P, right? O to P, this is 90 degree, and this OP is the hypotenuse of this right angle triangle, and the angle alpha will be O, right? It's from O, so it's between here is BOP, right? BOP will be the angle beta, right? You see here, if you see better picture, BOP, right? BOP will be the angle from y-axis to the vector OP, right? BOP. So then you have to find the beta later. Then later on, there is also an angle. This vector is not only forming the angle to x and y axis, it's also forming an angle from the z axis. Alright, let's see how to see it. Alright, now let's find the angle from the z axis. Okay, how to view the angle from the z axis to the vector OP. Right, so it will be from the z axis to the OP. So this is the angle. I leave it to be gamma. Alright, gamma. So it's from the z-axis to the OP. So in terms of the 3 dimension here, so how you view is from OC, right? OC. So OC is on the z-axis. So it's from OC to OP, right? The angle is from OC to OP. So I have to draw OP and C, we join together and forming a triangle. And PC is on a side of a cuboid, right? And this is perpendicular to OC, right? This is making a 90 degree here. Can you see that? They are actually a 90 degree here. So if I redrawing here, I can draw it such that OC, right? I can just redraw OC, right? P is above C, right? P is above C. So P, then I joining OC. So the angles between OC and OP, right? OC and OP will be the gamma, right? The angle gamma, which is this angle here. So then I have these 3 triangles so that I easy to explain to you how to finding the cosine angle, the direction cosine, right? So, so this is a complicated derivation. Hope you can understand. So as I can relate this into cos, so and I relate this as the length of A. All right, I can represent this as A because this is the length, right? O to X here, right? A, right? O to A. So this is your B, right? This is your C, right? Your C. So means that O to C, I can name this to be the length is A, this is the length is B, right? The length is B and the length for this is C. So means that this is B and this is C, right? And this is always the magnitude of OP, right? Magnitude of OP, and this is also the magnitude of OP, the length for O from O to P. The length from O to P is the magnitude of OP, right? So how I'm going to relate these 3 into the cosine angle of alpha, beta, and gamma. Alright, okay, let's see how to relate. I know that cos alpha, right, based on this triangle, cos alpha is adjacent over hypotenuse, right? Is A over with the length of hypotenuse, which is the magnitude of OP, right? So the one that opposite to the 90 degree is the hypotenuse. And let's look at this cos alpha, right? And cos beta, right? Cos beta is the same as adjacent over hypotenuse, right? It's B over with magnitude of OP. And cos gamma is the same as, you know that cos gamma is the same as C over with magnitude of OP. Now I have written cos alpha, cos beta, cos gamma in terms of A magnitude of AB, B magnitude of OP, and C magnitude of OP. And all of this is called the direction cosine, the formula for direction cosine, right? Direction cosine. So, right, the first you have to understand what is direction ratio. Is the ratio of the coefficient of the vector A, B, C, right? So now direction cosine will be defined as this. Alright, later on I'm going to show you how to finding direction cosine. Alright, okay, let's look at the meanings of unit vector with direction cosine. Alright, now we have known that this is a formula for direction cosine. So for more easier, I want to tell you that actually direction cosine is you can find the direction cosine from the unit vector of OP, right? Because what is the unit vector of OP, right? OP, the unit vector of OP, right? Unit vector of vector OP is defined to be the vector OP divided by its magnitude, right? This is the definition for unit vector. And the magnitude of unit vector is always 1, right? So how to finding the unit vector? So means that the unit vector for OP, OP is actually AI plus with BJ plus with CK, right? Divided by the magnitude of OP. So if you're very good, you can see that actually you can relate unit vector to direction cosine. Right? When I'm talking so long-winded is because I want to deliver this. Right? Actually, if you see carefully, A divided by magnitude of OP, I, plus with B divided by magnitude of OP, J, plus with C divided by magnitude of OP, K. Right? Each of it divided by OP. If you see that, what is this? A divided by magnitude of OP, right? Which is the cos alpha. You can replace, means that the unit vector for OP can also define as cos alpha I plus with B over magnitude of OP will be cos beta J, right? Followed by cos gamma is C over magnitude of OP, which is cos gamma K, right? So the most important thing that I want to tell you now is if you want to find, if you want to find the direction cosine of a vector, of any vector, alright? So you always finding the unit vector first. After you finding the unit vector, the coefficient of I, J, and K will be the direction cosine of the vector. Alright? So another properties here will be, because unit vector, the magnitude of unit vector is always 1, right? So we can get another relationship here, whereas I can say that the square root, the magnitude of OP, which is the square root of cos square alpha, A square, B square plus C square, right? So cos square plus cos square beta plus with cos square gamma, the magnitude will be equals to 1. So then we get an important formula also where the cos square alpha plus with cos square beta plus with cos square gamma, square root, squaring both sides, 1 square, you are getting 1. as the triangle can relate by this formula here. From the concept of unit vector, cos square alpha plus with cos square beta plus with cos square gamma is equals to 1. Alright, because the magnitude of unit vector is always 1. This is what is the meaning of unit vector here. Alright, so I hope you understand the process of derivation here. So if you appreciate it, you will try to understand. Later on, I want to tell you that beside you finding the direction cosine and the direction ratio, you also can find the angles, the angle alpha, gamma, and beta. Alright, you can find the angles of alpha, beta, and gamma. Right? What is this angle? This angle alpha is the angle from the x-axis to the vector, right? And beta and gamma is the angle that with respect to y-axis, and this is the angle with respect to of the vector from the z-axis. So this is, we name it as direction angle. So there are 3 terms that you must know. So first, because in this video mainly I want to introduce what is direction ratio, what is direction cosine, and lastly, what is direction angle. You must finding the direction cosine before you finding the direction angle. So alpha, beta, gamma will tell you where's the location of point P. So this is the important thing that you must know. This is to find direction cosine, you must first finding the unit vector of that vector, so that for each component here, you were getting your cos alpha, cos beta, cos gamma. Alright, let's see the next video for examples about how to using all this concept here. Alright, that's all for this video.